I say good evening. Am I audible? Hello. Hello. Am I audible? Yes. Okay. So in the last session, we completed the NumPy and the Pandas library, and we have also seen how to load a CSV file and work with it and try to do some kind of operations with what comes under the Pandas library. There was a hands-on exercise in that. So I hope you guys are doing that exercises. And for today, we'll be focusing on uh, GeoPandas library, and we'll be actually starting with the, Python and the libraries which are important and which you will be using for all kind of geospatial workflows for that matter. So the one of the libraries that we'll be working with today for today is the GeoPandas library. So for the context, GeoPandas is like the Panda library only, which we studied in the last session. But the difference is basically that let's suppose if you want to work with maps in Python, uh, so it's basically the same way that you works with table in Excel, but the difference is maps are not just the tabular data. Maps are more like some kind of a shapes are there, either a point, either a line, or a polygon data are there. So that's where GeoPandas comes into the picture. Means whenever you need to deal with any kind of a tabular data, along with when it has some kind of a spatial information, means shapes and the geometries, then you will be using GeoPandas. So GeoPanda is basically what? It extends pandas to handle the geospatial data, means the vector, means the tabular data that you have using the Shapely geometry. Shapely is also one of the library uh, within the Python, which helps you with drawing shapes, geometries, and all these geometry kind of handling are done using the Shapely library. So whenever you're combining the Shapely library functionalities, means the shapes and the geometries, along with your vector data sets, means the tabular data sets, then there comes the GeoPanda. So like we understood what are data frames in the last session, which comes under the pandas. So if we are talking about GeoPandas, so it will be geodata frame rather than just a data frame. So means a data frame plus a geometry column should be there. That completely makes it a geodata frame. And what type of a geometry column will be there? Either those geometries will be a point geometries, either they can be a line string geometries, or it can be a polygon geometries. So that's how you define a geodata frame for that matter. So if you we just compare using the pandas and the geopandas, so rows and columns will be there. Number and text will be there in the pandas, whereas number, text, and shapes will be there in the geodata frame, means the geopandas. Then pandas will handle your Excel-like things, means CSV and tabular data, whereas geopandas will handle your tabular data along with the map-based information like shapes and geometries it will handle. So if we just try to compare between how a geodata frame and normal data frame would look like. So in a normal data frame, so like in a pandas data frame, which will come under panda, there will be, let's suppose, two columns and each will have values in it. So let's suppose A is the name, let's suppose B is the name, and the value is one, and then this is something how Panda will look like. But if you want to see how your GeoPanda will look like, it will have one column, attribute column, let's say name and place, And then last most important column, you will be having a geometry column, which is a mandatory column that it should be there in that. So what it will contain look like. So let's suppose A and then okay. So A, B are the names and one and two are the again the place values, and then geometry will look something like this. So if it's a point data set, it has a point geometries, it will be something like look something like this, like a point, and then in the brackets it will have longitudes and latitudes. If it's a polygon, here it will be written as polygon, and then there will be a series of polygon geometries. If it's a line, then here it will be line or line string, and then here, there, everything will be like a series of polygons for the line. So that's how GeoPandas store your geometry as one of the columns, and it will along with just not the lat long, it will also store the shape of your geometries. So either it's a polygon, line, and point. So point, line, polygon means the shape and the longitudes and the latitude value. Both of the things it will store in a geometry column in a geodata frame, whereas it will not be present in your pandas data frame. So how many types of geometries are there? So geometries are mostly like point, line, string, and polygon. And if we compare points, mostly will be tree, cities, hospital information. Line string will have roads, rivers. Polygon will have state, district, lake, these kind of information it will contain. Okay. So let's suppose you want to like create a geodata frame. In the last two sessions before pandas and numpy, we discussed how to create JSON file, how to create a GeoJSON file, how to create uh, CSV, all those things. But let's suppose you need to create a geodata frame. So how will you create a geodata frame? There are three things which are mandatory in a geodata frame. One is the attribute information, another is the geometry information, and then coordinates. Giving the coordinate is optional, but it's if you are giving the coordinate itself along whenever you are creating a geodata frame, it will always be good for your data. So first thing first, in order to use the GeoPanda library, we need to import GeoPandas. So we have imported GeoPandas as GPD. So this is done. And then we are trying to create a new geodata frame here. So GPD dot geodata frame is the function that you will be using to create a new geodata frame. And let's suppose this is some kind of a data you have. So in this dictionary, you have created two things. Name is one key, value is another key, and in this you are having some value, in this you are having some value. So you have just created a geodata frame here. So in this, basically you are having two rows and a column like name and value present within it. Then you have also defined a geometry, that what should be the geometry of these two values that you have, because for a geodata frame, geometries are must. So the geometries are point for now. So we have defined the point, and along with that, we have also given the longitudes and the latitudes of this. So that's done. And order should always be longitude first and latitude later, otherwise it will not recognize. Then we will define the coordinate system. So since we need to map and everything, so the by default word coordinate system is WGS 84. So for now, we are keeping it at WGS 84 only. So the coordinates will be in degrees only because we are defining the coordinates in the degrees here. If later on you need to do some kind of a calculation or everything, so obviously you need to convert it to some kind of a local projection system so that you can have a correct area calculation. We'll get into that in detail later. So by default, we have set a coordinate system to it. Uh, then we are just created a data frame here. So this is done, and now you're trying to print the CRS. So another property of geodata frame, whenever you are loading any data, you need to first check what is the coordinate system of my dataset, because any spatial layer that you have, it is irrelevant if it doesn't have correct coordinate system, because correct coordinate system only will help you to plot your points, your data into a map and give you a proper, nice, good result and with a lot of accuracy. So for that reason, coordinate systems are must and should be present within your data whenever you are working with any kind of special data for that matter. So if we just here only, we just deep down into what coordinate system is. So can anybody tell who is there in the class? Do you understand what coordinate system is and why it is important? Veena, Shelly, anybody? Okay, fine. So coordinate system basically it's important because it tells you exactly where on the earth your point is going to draw. So let's suppose if same places can have different coordinate system, such like simply like inches and centimeter are more or less similar, but they looks different. The values are different. The unit are different. They represent different things. So similarly, you can have similar areas into different coordinate system as per the use cases. That what is the use that you want to do. So let's suppose if you are having coordinate system in WGS 84, so that will be mostly used in case of GPS, Google Maps, displaying location, plotting it using Folium or leaflet. Means whenever you are dealing with the word level of data and there you want to reference your data and plot it, you will mostly be using WGS 84. But let's suppose you want to do some kind of a localized calculation, area, distance calculation, and mapping, centroid calculation. Then our Earth is sphere. So in that case, we need to first project our coordinate system into some kind of a flat surface, flat map kind of a thing. Then you can do the calculation. Simply like, let's suppose you want to calculate the area. So if I want to calculate the area of this particular polygon, so obviously if I am calculating the area in a curved surface, I'll be getting a wrong result. So I will first project my whole map into a kind of a flat map. Once this is flat, then I'll then calculate the area, and then it will basically give me correct area. So that's why if you convert it into some kind of a local projection system, UTM, or there is things like EPSG 6933. So those things will help you for area calculation, for distance calculation, and for length calculation. So always first convert your coordinate system into a local projections coordinate system. Then it will help you for the calculation part. So, yeah, this is done. Another thing, like once you are creating a geodata frame and you are defining the geometry and everything, so this actually it's coming from the Shapely library. Shapely.geometry import polygon point and polygon. So you need to import this point and polygon from Shapely.geometry. Then only you will be able to define this point here and you will be able to raw shape out of it. So that's why first we imported the GeoPanda library so that we can have geodata frame and which and then we will call it as GPD. And then after that we are importing the Shapely by so that you can create a geometric shape out of it, like point, single location, polygon for closed area, states or district for that matter. Then here we created a geodata frame and it will have Excel-like columns, attribute information, along with some kind of map information, means geometry information in this. And then we print it. So right now the coordinate system of this is EPSG 4326. So once we are done, now we let's suppose you need to do some area calculation. Then for that matter, we will convert the coordinate system into a flat uh, map area. So there is another word cylindrical equal area projection system, which is 6933, which helps you to calculate the equal area and it will give you more accurate and correct area, and it is required for area, distance, and centroid. Again, now the unit of your calculations will be in meters, whereas in EPSG, the unit it was in degree and Celsius, so you will not get accurate area. In the UTM ones, like these ones, equal area, the units are in meter, so it will give you correct output. Just a minute. Okay. So creating a geodata frame for a point data set is not a issue, but let's suppose you want to create a polygon, and for that, you need to define a polygon geometry. So, for that, it is really tough for you to create a polygon geometry because polygon geometries are not straightforward like lat long and lat long. There are a series of latitudes and longitudes which come back to that exact same geometry if you want to create one. Because let's suppose you are drawing a polygon like this, so the coordinate of this particular point should match with the coordinate once it has come again. So it should be a ring of polygon rather than random point polygon lat and long. It will be a series of lat long from here to here to here, and then it will close back here in this location. So it's not humanly possible that you just keep on giving the latitudes and longitudes for every single location to draw a polygon. So for that matter, uh, basically what you need to do, you will just simply give four uh, coordinates, like from the end here, from the start to end, you will give four corner points we have defined here. First and last point will connect automatically. So so we have just normally given a four corner points here, and then it is representing a 1 by 1 square. So now we have given the first and the last point, first point corner and the last point corner. And then, sorry, 4 point corner we have given 1, 2, 3, and 4. Okay. So now what we are giving, we are creating a geoseries because we want to create a series of polygon from here to here. Why we need to create series of polygons? Because we need to close it from and give every single coordinate from point to point from here to here. So for that case, we used a function named geoseries. In this, we will use a function named geoseries, and then we will give our polygons coordinate here. We will define our coordinate system here. So once this is done, what it will do, it will create a polygon for you. We have created a polygon geometry with the help of 4326 here. And then once we created here, what you will be doing, you will be again converting into to flat map area. Why we are converting it into a flat map area? Because we have to now do some area calculation for this polygon. So if you want to do the area calculation, we need it to convert it into some kind of a UTM. So again, we have converted polygs dot to CRS. 2CRS will help you to change the coordinate system. Then EPSG 6933. It is done. Now, if you want to calculate the area out of this, so we'll use a function dot dot area, and then we will use dot iloc 0. Divide by this, we are dividing by this because so that we can just have the area into kilometer square. That's why we are dividing it from this particular number, 10 to power 6. And then once we get the area here, area in this, let's once you get the area here, then we will calculate the centroid also. Centroid means for that particular polygon, you want to calculate the center point of that polygon. So there is a function named centroid, which will give you the centroid of that particular point, that particular, not point, that particular polygon. So poly area you have defined here and dot centroid. Since we needed to do two types of calculation, one was area calculation, another was centroid calculation, and that will be accurate only when you have projected coordinate system. So poly area AEA dot centroid will give you centroid of that particular polygon. Now we are again converting it back to the WGS coordinate system so that it looks in the degree Celsius format so that you can represent the centroid, because people understand latitudes, longitude in degree Celsius rather than in a metric form, meter or any kind of a unit. Meter is helpful only for calculation, whereas for representation of or geometrical points or polygons, you will always prefer uh, latitudes and longitudes in degree Celsius. So we have the area, we have the centroid. Now we can simply print it. So here I am trying to print area kilometer square. So area kilometer square, the variable name is this. We used f string here. I have already explained multiple times why we use f string, so that we can just give our variable here and the value will come here. Dot 1f is used for the round off. Similarly, for the centroid, we pass the centroid value here. Dot centroid will come with xy as a combine. Then if you want to print it separately, the x and y will print it like this. So always remember, it's always longitudes and latitudes. So that's why for latitude, I am printing centroid WGS84.y, whereas for longitude, I am printing centroid WGS84x, because in map terms, in Python terms, it is always longitudes first and latitudes later. Do not get confused in this. Now, I'll now run this whole thing. So you can now see it has given you the output. The input CRS was this. Area is 10,850.3 kilometers for the polygon that you just created here. And then we calculated the centroid as well. And once you created the centroid, it has given you latitudes and longitudes in degrees Celsius. Why? Because you have converted it back to because you have converted it back to the word coordinate system, WGS84. That's why it's in latitudes and longitudes. Okay, so I hope the GeoPandas are a little bit clear how you can work with GeoPandas. Now we'll try to do a real example using the GeoPandas. We will just here the exercise is basically in this exercise it's something different written, like you need to install GeoPanda first. In our case, GeoPandas is already installed. You need to then import it. After import it, you need to read any kind of a layer, which is a GeoJSON or a shapefile. After reading that, you need to first understand what the coordinate system is. Then when you understand what the coordinate system is, then you need to reproject the coordinate system into some kind of an equal area or a UTM project system so that you can do area calculations properly. Then after that, you need to calculate the centroid for all those polygon layer. Let's suppose you have a state boundary. You have a shapefile which contains state level boundary for India. And then you need to calculate the area of every single state. And then you need to calculate the centroid for every single state. And then at last, you need to print the summary of all the states with the value of the centroid and with the value of with the location of the centroids and the area for all the states, and then you need to sort all the state with the help of a name. So that's the exercise that I want you to do. We are doing an extensive exercise for the same with the same pattern. This you can do later on as per your pace after learning what we are trying to do here. So for today, we'll just take a file. I have also shared this data set for you with you so that you can practice. Let's suppose you have a folder which contains shapefile information in this. So there are multiple files. You already know that when you have a shapefile, there are other associated files that comes with it. But whenever you are loading any shapefile in Colab, you only need to load .shp, but this folder should contain everything. Okay. So I just loaded my 2011 district shapefile. And then first thing first, whenever you are working with your data, and you always need to make sure that what kind of data is present. You need to first check your data. So because it's highly unlikely that you are pre-aware what all fields present in my data. So for that matter, I just loaded. Then I am checking doing the dot head. What dot head will do? Dot head is the method that gives you first five rows of your database. So GDF is the geodata frame that we created. The geodata frame that we were creating here we were creating it manually. Now we are loading it with the file that we have, and then we are just saving it in a GDF. So GDF is a geodata frame. Then after that, we will do dot head. What dot head will do? It will give you first five layers. Now you can see what all it has. It has few attribute information, means a tabular information. Then along with that, it also has a geometry column. And that geometry column does not only contain the latitudes and the longitudes, it also has the shape of that polygon. So in our case, you can see that first that geometry column is mentioned that what is the shape of the geometry. So it is a polygon and it is a multi-polygon or it is something else. It will mention here. Along with that, it will just print all the latitudes and longitudes also. It will contain everything in this particular column. So we are good to go. We have loaded our layer. We have loaded our data. We understood what all data we have. And then we'll try to do some kind of a operations with this and try to generate insights with this. So for today, our two main agenda is there that I need to find state-wise a centroid and state-wise area for my dataset. But here is the catch that in my dataset, I don't have geometries for the states. I only have geometries for the district level. So first, now before getting to the level that I calculate the area for my state polygon, I need to first mm, combine, or I'll say I need to first dissolve my areas, my geometries from the district polygons to make it a state polygon. Then only I will be able to calculate the statistical information for my state polygon. So before that, we will try to plot what current data we have so we can, along with the tabular view, we can also get a map view so that we can get a more information out of it and look how we can see once how it looks like. So for plotting, we have imported a library called matplotlib. This import matplotlib by pyplot as PLT. We have imported this. With the help of this library, we will try to make a plot out of it. So again, we have passed figure AX and then we have subplot, define the height and width and everything. And then how many columns I need. Maybe I want to fit in two maps here. So I can just change with the subplots. But right now I only want one plot. So I am writing 1,1. Figure size is basically width and height. And then here you will pass your data frame and write all the style information within this plot. So GDF is my data frame, which I want to plot. GDF is my data frame, which I want to plot. Dot plot is the function that you use to make the plots. AX is equals to AX, simple for mapping. Then you will define column name, that on the basis of which column name you want to give the color. Like similarly, how you assign symbology in mapping softwares. So you define a column that on the basis of this column, you need colors, you need to set the symbology and all these things. So here also, I want color on the basis of the state name. Then line width is basically the boundary that you want to give. Edge color, what is the boundary color that you want? And legend, I don't want legend for now, so legend is false. AX dot set title will set the title of my plot. AX dot X is off means I'm not drawing those grids format for now. PLT dot show simply give me plot. Okay. So you can see now my map is looking something like this. So if I want to calculate state by uh, area in terms of states, so what I need to do? First, I need to dissolve all these boundaries first. Whatever inside boundaries, district level boundaries that we have in my data, I need to dissolve them. Then only I can calculate the area as per the state. There is another way that you calculate the area for every single district and then do the group by and then add on the area for every single district to calculate the state-wise area. That is also an option. But since here we need centroid as well for the state, so we'll be doing otherwise, like the vice versa. We are first dissolving the geometries for the states to create a uniform geometry for a single state, and then we'll be doing the statistical calculation. So what is the method for dissolving the geometry? Simple. GDF, you have to pass on your data, dot dissolve. Dot dissolve will basically merge all your geometries into one. Then by which field you want to do the dissolve. So I want to dissolve on the basis of the state name. So what it will do, it will group every geometry from the district column as per the state, like it will create single block for every single state first, and then it will just dissolve everything. So we will run this. And now we will again do the plotting to understand how it looks after the dissolve. So now you can see we have dissolved all the geometries here within this. Now we have created state-wise layer from our district-wise layer. So this is done. Next thing is now I'll check my till now CRS was not the concern for me because I was just doing the plotting. So it can happen with W4326 like WGS. But now we are moving forward with geometrical operations, calculations, the area calculation, centroid calculation. So now for me, coordinate system is important. So first I will try to know what is the current coordinate system. So the current coordinate system you can know by using states.crs. Why I'm doing states.crs? Because now from the GDF geodata frame, we have created a different geodata frame, which is a state. So GDF geodata frame will contain district-wise information, whereas state geodata frame will contain state-wise information. So now my concern is only with state geodata frame. So this is a different geodata frame, and this is a different geodata frame. So I am concerned only with states for now. So then I will check the coordinate system for state geodata frame only. So .crs will help me to know what is the coordinate system. Then I want to convert the coordinate system. Why I want to convert? Because I want to do the area calculation. So I converted into 6933 for now. Then I have saved, again made a new data frame out of that after converting, which is a states underscore AEA. So this is the converted geodata frame, which has coordinate system 6933. So I will use this geodata frame for my area calculation. Once you have this, now I need to add one more new column to my data frame. Why I need to add new column? Because in that new column only, I will calculate the geometries and I'll try to put that calculated geometry into that. So this is how you can add on new column. So this is the data frame name, states underscore AEA, and this is the name of the new column that I want to add. Then states underscore AEA dot geometry dot area. This will This will calculate the area for you, and then we are again dividing by this so that we can have the area in square kilometers. And we will just run this. Where did you get the EPSG values? You can just normally search that this is my requirement and what's the coordinate system that I can use for this. Like for example, like this EPSG values for area calculation. I can just search it like this. So this is also you can use. And area calculation also depend upon what's the area that you have. So maybe area calculation in India. So apsg.io. This will give for India, you can have the details here. It will give you state-wise different that here it's 4410, here it's 4411 and 4409. I'll search if for other countries. For USA, yes, for USA, you can just search like this here. I'll just share this. You can explore this. You can have this link. By this link, you can just search the correct TPSJ for your exact local area. Okay. So we converted for now into this. And then once this is done, then I need to, I was trying to fetch the heads. Okay, now you can see that I have added a new column. So earlier in my data frame, it was only earlier in this data frame, it was district, state name, this. But once we merged into states, this states, once I merged it, now in my new one, I have state name, the geometry of the new layer that I have, so geometry of that, then the district name also we have, and then all the other information, sensor code, and then at last, this is the important one, which I have is area, which we added from here. So I have everything here. Now I want to calculate the centroid. So I'll again add a new uh, column named centroid and I'll calculate the centroid. For calculating the centroid, again, the method is geometry dot centroid. So you will run this and then we'll try to check the heads again. So now you can see that you have centroid as well. Centroid will be a point geometry only, which will be the center of every single polygon that you have. So it will be a point. So it has given you the geometry for that. You can just see here that right now, if I am printing the head, my latitudes and longitudes are in meter because we have converted it into a different UTM projection system. Whereas in this, if you can just focus and try to look into this, right now your coordinate system are in degree 78 point this. So because here the coordinate system was WGS 84. So these are the small things, but are very important when you are working in real life projects because this can actually hamper what exact result you want to display as an output. So coordinate systems are very important whenever you are dealing with any kind of a bigger or a real life projects. So yes, we are good to go. We have the centroids. Now we have the area, we have the data frame. Now my requirement is I want to map everything. So if I want to map everything, so first thing first, before that, I'll again convert it back to 4326. Why am I'm converting it back to 4326? Because I want to map it, and for mapping, I need everything in latitude and longitude format, like a degree Celsius format, rather than these metric calculation format. These are important till the point we were doing the calculation. So what I'm trying to do here, just you need to focus a little more. Whatever centroid we calculated, we added in a states underscore AEA data frame. My state data frame is still the same. My state data frame still have only this information. Just a minute. If I'm printing, it still has state name and other information. It still doesn't have the areas or the centroid. It doesn't have anything like that because we have stored calculated area and centroid in states underscore AEA data frame. Okay. So what we are doing, we are just adding the centroid column from this state data frame to our main states from states underscore AE data frame to our main states data frame. We are adding this column. Why we are adding this column? So that we can map it when I want to create a map. So from here I'm shifting this to there and also along with converting it into 43226. So there are two things which I'm doing here. First, I am creating a new column named centroid in my previous data frame, which was states, which was our main data frame, using the current data frame that we created for the calculation part only. Since this column contains centroids in UTM projection system, I wanted back to 4326 for my mapping requirements because the coordinate system for state is still 4326. So I am doing states underscore AEA, fetch the field, then convert that field to this particular coordinate system. So we used dot underscore two underscore PRS. And here we added a new column. I'll just run this. Once I am running this, if I now print the head, you can see I have added a new column here in this state. So that's how you can like uh, play around, manipulate, work with your data, add data frame, subtract data frame, create new tables, and just map your requirement and get your results. Because if you're working in a QGIS and ArcGIS software, if somebody has worked on that software, for these small thing, you need to do a lot of things. Like you need to first create the layer, just add the column into new column. But here with a single short 2-3 line of scripts, you can just manipulate with the data frames, join, do the special join, do the attribute join, and get the result. You will get more hands-on like examples for this once we move ahead. But just try to understand the overall picture that how much you can do using all these functions that we are doing right now. Now I want to just print the summary because my requirement was calculate the area and give me the area in terms of state and then order it. That was the requirement for my exercise. So I'm just trying to print a state summary. In this state summary, what I have done, I have my states underscore AEA data frame. In that, I have only fetched two fields from this state name and area kilometer square. I only need two fields. I don't need any other fields for my data frame. That's not my requirement for now. So I have just created a subset out of that. Once I created the subset, I am trying to sort the values. Why I'm trying to sort the values? Because I need the values in the order like from A, B, C, D, and that way. With what field you want, I want to sort using the state name field, and uh, I am just dropping the index for now. So that's why I reset the index. We're resetting the index, what is already set in the data frame, so that we can create a new index for this new sorting that we are creating. So we just run this. This is a new thing that we created. New data frame basically we created out of the previous data frames that we have. And then simply we just print it. Now we got all the state values, everything, states and everything, every single polygon that we had, and then area as well in square kilometer like this. Now, since whatever data frames that we create, we try to plot two things. We will try to plot the state on the base, and then we'll try to plot the centroid as well. So that was the reason that I added centroid field into our main data frame. So for plotting the two layers, like on top of that, from a single data frame, I'm trying to plot two different things by using two different fields. So first thing first, I just plotted my whole state boundary. Then I don't need to define that which field to choose. So I just plotted state here, states dot plot, and then I defined a edge color and I defined a base color. And then I need to plot the centroid, means on the basis of some field value I want to plot. So that's why I have defined my data frame. And then I have passed on that which field to choose to plot. So plot the centroid field for now. And then again, since the centroid is a point geometry, we have defined this marker size here, that what should be the marker size and what should be the color of that marker. Set the title, set the axis as off, and plt dot show. Now, if you run this, you get something like this. On top of the India base map, which we created after dissolving the district-wise layers, you calculated the centroid, and then once you calculated the centroid, you have just plotted all those centroid value as well as here. Oh, okay. So this is it. Another important, like just a curious thing I want you to explore. Let's suppose we have everything till now. We have areas as well. What if you want to map, instead of giving similar color, you want to do the color mapping as per area and with legends, so that color wise there should be a distinction, like, and there should be a color map here and there should be a legend on the side. That's the requirement. uh, we will do this later on, like in the track 3. It's everything, it's all about mapping and coloring and visualization and everything after doing the analysis. But if you can do it, just a practice exercise, no pressure for this color mapping. Okay. So any question? Because like this is it for today's class. I have only this for today. If there's any confusion what we discussed today, you can let me know. Umar, if you're trying to speak, I can't hear you. Okay, then we'll just okay, no problem. Okay, then we'll close this for today. And if there's anything, you can ask me in the next session. Bye, everyone. Good night.